Welcome back. I'm Miss Lisa, and this is my YouTube channel for everything I want to talk about, science and math. And today we're doing physics, and this is the last video for the physics class. Yay! Celebration! I'm wearing my party hat, but you can't see it. Like, I'll come around here, like, party hat, woohoo! There's the party hat. Anyway, so what we're going to do is the math of the magnetism. And if you look, there's more book here. So if you want to do it, go find some videos on it. It's out there. Every topic that is in this book, you can find a video on, and you'll probably find someone you even like better than me. It won't hurt my feelings. All right, so we're going to talk about the math in this chapter with the magnetism. Let me go flip back. Am I at the beginning of the chapter? No, I'm not. Okay, so one of the things I didn't talk about in the last video was that the northern lights are caused by the solar particles interacting with the Earth's magnetic field, is the best they understand it. So that's cool. Notice that I live down here in the southeast, that we don't get northern lights down here. But I found out as I was researching it that there have been times where they've actually made it down south. I don't know if as far as I live south, but when it does that, sometimes in the south, instead of having northern lights, we have something called blue inoculant clouds, which are these glowy blue clouds, and I have seen that before in my life. So I've seen the glowy blue clouds before. But anyway, so that would be fun to research some more about that, wouldn't it? So if we had been in class, we would have had magnets, paper, iron filings. I have a flashlight that you can shake, this electromagnet. I would have brought out a voltmeter, bar magnets, a compass, iron filings, paper clips, because magnetism is sort of like it's contagious. If you have a magnet and you touch one paper clip, then you can pick up another and another and another with that chain of paper clips. So that's kind of fun. All right, so there's some magnets there. There's our bar magnets, where I told you if you break it in half, it'll become two different ones. And that likes repel, these are repelling, and opposites attract. Okay, so here are the magnetic field lines that go around, there's my pretend magnet, that go around a magnet. And you can see this is like the iron filings. And here you can see that the like ends are attracting, and then the unlike ends are not for poles. Like poles that are attracting, and unlike like poles that are repelling, and like poles that are attracting. You can see that attraction and repulsion right there. So that's kind of interesting. Okay, and different kinds of magnets. One time I bought a magnet that I thought was an actual curved around magnet. They just had little magnets on each end. It was at a homeschool fair. Here's how you do the right hand rule, and it shows you the direction of the current and the direction of the magnetic field lines. So that's kind of fun. There's an electromagnet. That's fun too. Here are the little particles that go in all different directions, where the piece of metal wouldn't be magnetic. And here they're all lined up, and they will be magnetic. So they're making an electromagnet, which I told you could do for your lab. See, this is where I said that the magnetic poles of the Earth have changed a lot of times, they think, and that it might affect us if it does it again. All right, so we're about to do the math here. And our first formula is F equals Bill. See, it looks like Bill. B is the magnetic field. I is the current, just like it was before. F is the force, and L is the length of the wire. All right? So let's see if there's anything here. Some more little right-hand rules that will show you just some more little things you can read about that. So here is our Earth, the magnetic North Pole, South Pole, same as the real South Pole, magnetic South. So our magnetic field lines go out and up like that. Okay, let's look at example problem number 1. calculating the strength of a magnetic field. A wire of 0.1 meter long carries a current of 5 amps. The wire is at right angles into a uniform magnetic field. The force on the wire is 0.2 newtons. What is the magnitude of the magnetic field B? So those are our knowns and unknowns. Our basic equation is our force equals Bill equation, but they rearranged it for B, filled it in, and got 0.40. So that's what we got for the force of the magnetic field. Let's see if I did it. Oh, yes, I did it over here because I don't like to rearrange. So here is F equals Bill. 20 is B times 0.1 times 5. So you multiply these together and then divide it into 20 and you get 0.4T. Just what they got. Okay, problem number 2. A wire 115 meters long is at right angles to a uniform magnetic field. The field has a magnetic field strength of 5 times 10 to the negative 5th, big T, which is the strength of the field. The current through the wire is 400 amps. Find the magnitude of the force. So that's our knowns and unknowns. Here is our F equals Bill, and this time we just put it in, multiply it together, and we get 2.3 newtons. All right, is that it? Oh, here's example problem number 3. A beam of electrons travels at 3 times 10 to the negative 6 meters per second through a 4 times 10 to the negative second magnetic field. The beam is at right angles to the magnetic field. What is the magnitude of the force acting on each electron? So that's our volts, that's our magnetic field. What's the force? And remember that Q on electrons is constant. It's 1.6 times 10 to the negative 19th coulombs. So that's a constant, which they gave us right there. So F equals BQV. So that's B, that's Q, that's V, and that's the answer. 1.9 times 10 to the negative 14 newtons. Okay? The next one says, compare the force acting on a proton moving at the same speed in the same direction to the force acting on an electron in part A. So the force on the proton is the same because the same charge magnitude, but opposite direction because it is positive. All right, so that's pretty easy. And that's it. We have made it to the end. So like I said, if you want to keep going and learn more about other things in physics, feel free. There are plenty of videos on YouTube. Look at Peterson Science and see if he's got some. I know he's got some more honors and AP level classes with all the videos on. Also, Tyler DeWitt has some good videos. I don't know if they're all chemistry, but I like him a lot also. But you can just go find your own. One of my favorite physics professor is Paul Hewitt. I would definitely go watch him. Paul Hewitt. Now, that shows you what a nerd I am, is that I have a favorite textbook writer, and it's not this one. It's Paul Hewitt. Go watch his videos. Those are awesome. He is just terrific. And he wrote Conceptual Physics. So I would definitely buy a copy of Conceptual Physics. And when you take college physics, read Conceptual Physics and your college physics book so that you understand it better. Because he does a great job of really explaining the concepts. And he's a great artist and does great little drawings too. All right? So I hope you had fun. I did. Tell others about it. Get them to like, share, and subscribe. And remember, science is great.